This is the SVG file that defines the laser cut parts for the big button. I've done my best to fit it onto as little plywood as possible, but it still is going to take 2 sheets of 600 by 400 mil ply. I've done my best to put all the waste together so that maybe you'll be able to reuse some of that ply for other projects. It's really important that you use 3mm ply because a number of the features of this design rely on it being cut in 3mm ply. The finger joints, for example, and the size of the cavity for the Raspberry Pi screen both rely on the depth of the material, being 3 mils. The first sheet of ply that you're going to need to cut has a number of important parts for the button. We have the front piece, which has the hole for the screen, hole for the camera. If you don't want to install a camera, you could exclude that hole from your cut. And it has finger joints all the way around for the sides and holes for finger joints for the support for the button mechanism. The back similarly has those same finger joints holes for the support mechanism for the button, and it has the joints all the way around. Additionally, it has 4 windows that get cut, which we put lights behind. That support mechanism, the support piece that holds the sponge, which is the spring, and on top of that is stacked the rest of the button, is this piece here. You'll see that I've cut a slot in it, which allows the ribbon cable to go through to the Raspberry Pi from the Raspberry Pi camera. I've also left 2 other holes to make routing wires from the button contacts simpler, because there's not that much space up in the top of the button, so I figured I'd cut some holes to make putting the wires through a bit more straightforward. There's 2 other pieces that make up the top of the button. There's these 2 pieces here, this one and this one, which are the angled sides of the button, and there's the top piece, which is what the 3D parts for the button mechanism all slot through, and that goes on the very top. Additionally, on this sheet of ply, we also have the parts to make the hole which we put the Raspberry Pi screen into. We have to make a hole that is 9mm deep. So first we've got the 3mm of the front surface, and then we need to pad it by another 2 layers of ply. To make this, we have these parts here, which make one surround, which we glue on the inside around here, and then we have another set of 4 of these angle pieces. Again, highlight them, which we stack up on top of that, again on the back of the front piece. This gives us our 9mm deep hole, which we then back with this piece here, which has the supports and the screw holes for the Raspberry Pi. You'll notice that we have a little cutaway notch here. This makes it more straightforward to attach the micro USB to the Raspberry Pi without it catching on the frame. Also, this is helpful because this notch needs to be at the bottom of the screen, so it helps us to locate the parts correctly when we're putting it all together. If you put the frame and the all the screen supports in the case properly, you can't put the screen in upside down. It will only fit in one way, so you won't end up with having an upside down picture. We also have 4 holes in here, which are for the 4 screws that hold on the Raspberry Pi screen. The Raspberry Pi itself is screwed to the screen. The screws I had were a little bit too long, so I also cut these 4 washers, which I just stuck on these holes just to allow me to use slightly longer screws without damaging the screen. On the second sheet of ply we're going to cut, we have the left and right pieces. These are cut with the amazing kind of living hinge or sort of flexi ply cuts. I still find this fantastic that you can take a perfectly rigid sheet of ply, go at it with a laser cutter and end up with something that's really floppy and you can wrap around a curve. So that's what these sections allow us to do. These pieces have a hole in the bottom which allows access to the internals when we're putting it together, and they have holes for the finger joints for the light bar. The light bar is here. This again slots into the left and right pieces and holds on the lights behind the windows. And has holes in it so we have access to the mounting holes for the Raspberry Pi screen. This final piece is what goes on the inside of this bottom hole, and it's what we screw our feet into. We glue some nuts onto there and bolt through, and it has a hole in the middle to allow the wire out. In this whole design, all the black lines are cuts. There's only one green line, but that green line is a score, and I just use it to help locate the sponge centrally on the plinth that holds it. And now these are the parts for the mini button. It's a little bit simpler. It's basically just a box. In this design, we again using black for cuts, green for scores, and additionally we also have some blue, which I use to be I use for engraving. So we engrave in the front piece. We engrave a design that makes it look a bit like the button from the TV show. Again, the top piece is exactly the same sort of idea as we had before. It's got a hole in for 3D parts to go through. There's a piece that supports the sponge, which acts as a spring and supports the whole button mechanism. That's this piece here, and that slots into the left and right sides. There's a back piece which has quite a big access hole to allow access to the Raspberry Pi and HDMI, things like that. One of the sides has a small slot in it to allow access to the SD card, and also for the older Raspberry Pi design, you can also run the power cable in and out of that hole. The bottom piece has holes in it for the Raspberry Pi, and it has a score to sort of show where the Raspberry Pi is located. There's two versions of this design, one for the older Raspberry Pi and one for the newer models, with slightly different locations of screw holes. We also have some feet down here which get glued to the bottom piece to just lift it off the surface slightly, and we have 4 spacers which we use to raise the Raspberry Pi itself away from the bottom piece. Even for the old Raspberry Pis, which only have 2 screw holes, we still have 4 spacers because the SD card is that much thicker on the old one, so we need to offset it from the base by 6mm. With the new one, we need to offset it by 3mm. But we have four screws on the new one, 2 screws in the old one, so either way round, we still need 4 little washers. So we just cut those here. I'd just like to give a shout out to the creator of Boxes.pi. All these finger joints and also the flexi ply living hinge pieces on the big button were all designed using Boxes.pi. I think it's a brilliant tool, and thank you very much for making it. This is the design for the 3D printed parts for the button. These parts are common to both the button and also the mini button, the small button. This design actually contains 3 parts. We have a dome, which is the dome of the button. In fact, we 3D print this in ABS, and then we use it as a former to vacuum form a much thinner plastic dome, which is translucent and allows us to project light through it to make it change colour between red and green. But we have to 3D print the former first. I mean, I guess if you had a dome of the right size already knocking around, you could use that as your vacuum forming former, but I 3D printed one ABS. That sits on top of this shaft piece. This is what the electronics sits on top of. It has a large hole in the middle to allow wires through, and it has a small taper on all around the edge, which allows the vacuum formed dome to sit on nicely. It also has 4 locating lugs all the way around, which allow it to slot, which match up with the ones in the laser cut parts and stop it rotating. It in turn sits on top of a base. This base is located inside the button case, so the button case kind of the top piece sits between these 2 parts and it slides up and down through the top piece. This is quite a straightforward piece. It's just a flat circular flat ring with a small lip to help locate it on the shaft. This is what we coat with copper tape to make some of the contacts. So these 3 pieces all need to be 3D printed for both versions of the button. As I said, this dome is actually the biggest piece and will take the longest time to print, but will ultimately be thrown away because we only use it as a former. I did it in ABS, so it would be more resilient to the heat of the vacuum former. You might get away with doing it in PLA. Because we don't need this part to be that robust, you may get away with doing it with less infill, or I certainly didn't do it at a very high quality. And it did a good job on the vacuum forming. And in fact, I've vacuum formed about 4 or 5 domes from it, and it's still showing no signs of degrading. So maybe ABS was a good choice. I didn't try PLA, so maybe it would have been a good choice too. The rest of the button parts I have printed in both ABS and PLA, and both seem to work fine. I only printed them in ABS because in the makespace where I do my 3D printing, there's often less queue for the ABS printers because people find them a bit trickier to use. So I printed some parts in ABS just to get on quicker. This is the 3D design for the feet or the legs for the button. This is only required for the button or the big button, so the small one doesn't use it. It's a single piece. I've printed this in both ABS and PLA. It should print without any support. You want to print it obviously with the legs in the air, and as you can see, it's got holes in the bottom for bolts to go through, and they match up with the nuts on a panel that we put inside the button to hold it in place. And it's got a hole in the middle which allows the wires to come out. It's quite a big piece. It's maybe the longest print of all the parts required, but you don't have to print it at particularly high quality. Do it quite a big layer step, and then maybe, because ultimately it's kind of hidden under the button case, you want it to be there and look the right shape, but people aren't going to be interacting with it greatly.